to another problem for algebra, page 373, number 19. This one's a little bit more involved because we're following the same steps as before, where we want to have our equation in a y equals mx plus b form, our slope-intercept form. The problem is that this is not anywhere near that. You'll notice that our y is not in the right place, our m isn't either, our mx, our y-intercept seems to be okay. So we want to do our best to make this into its y equals mx plus b. So you'll notice that the the x variable is on the left side of the equation. So we want to move it to the right. Okay, so we want to subtract. We want to do or add the opposite of what's there right now. So we add a negative 4x on our right equation and a negative 6x on the left equation. So we want to move it over to the right side of the equation, and we accomplish that. And these are the equations that we have now, our new equations. You'll notice that the equation on the right, we have a y equals negative 6x plus 37. That's right there a y equals mx plus b. Okay, so we have the form that we want on the left side. You'll notice on the right side we have a 2y equals negative 4x plus 18. So we're almost there. All the variables are on the right side of the equation, or on the correct side of the equation. We just have a 2 attached to the y that we want to get rid of. And we know that it's attached by multiplication, so to move it over to the opposite side, we will do division, divide by 2. So whatever we do to one side of the equation, you know that we have to do to the entire side of the other. So that's dividing that whole side by 2. That gives us our y. Now we're just inching closer to where we want to be. So we're dividing each of those terms by 2. Back up, negative 4x divided by 2 gives us negative 2x. And then 18 divided by 2 gives us plus 9. You notice it was a plus 18 over 2, so that's plus 9. Now we have our slope-intercept form. So the next thing that we want to do is now graph it. We want to graph both of these and check our solution. Okay, so I did actually something a little different here. I'll show you what it looks like graphed in a second. But I did something called substitution because it just seemed to be the easiest way to go about this at this point, even though the next section does deal with substitution method throughout the entire section. I just wanted to go ahead and show you what that is, what that looks like right now. So you'll notice that we have our y equals and then some term on the right-hand side. So we know what y equals now. And for each of these equations, it equals something a little bit different. But for our own sake, for algebra's sake, we know that y is the same variable for both of these equations. So what we can actually do now is we can pit these together. Since y equals y, right, that makes good logical sense, we can say that the terms on the right-hand side also equal each other, giving us a new equation that looks like this, right? Because again, logically, we know y always equals y. And for these equations, we have said that these terms, negative 6x plus 37 equals y also. And then on the right side, we said negative 2x plus 9 also equals y. So then we can just put those together to say y equals y, or these terms, negative 6x plus 37 equals 2x plus 9. And you'll notice that with this new equation, we only have now one variable. We have x. We've eliminated the y variable. This will actually help us in identifying what that x coordinate is. Keep in mind also, keep the big picture in mind that we're still dealing with coordinate points. We're trying to find the coordinate points that both of these lines have in common. So by doing this, we'll be able to find the exact x coordinate point. So now we just got to do a little bit of algebra. Okay, I'm subtracting 9 from my right side. I'm moving it over to my left, so I have to subtract by 9, right? Okay, so that will get rid of my 9, and then 37 minus 9 is 28, yes? So then I'm going to move my 6x, I'm going to move it over to the right-hand side. So since it's a negative 6, I need to add a positive 6. So then I have on my right side, negative 2x plus 6x, and then that gives me 4x, and then I'm left with my 28 term by itself. Let me do that again so you can see that. Okay, so this is what I'm left with. This is my new equation. It's 4x equals 28. So now it's as simple as dividing by 4. 28 divided by 4 gives me x equals 7. Okay, so x does in fact equal 7. So I now have the coordinate point for the x coordinate point for this equation. Now all I have to do is use this point, and I can input this this term into any one of my equations up there. I can input it to any one of those two, and that will give me the y. I'm going to go ahead and choose 2x, negative 2x plus 9, because it's a little easier than the negative 6x. Can I do this? Absolutely. But I'm just going to go with the path of least resistance for now. So negative 2x will be, x will now be 7, because that's the value I found it to be. So negative 2 times 7 is negative 14, plus 9 is negative 5. Now I have my y coordinate. I have my x coordinate and my y coordinate, which is 7 and negative 5. And this, in fact, algebraically is the solution to my linear system. So these two equations, if I were to graph them, and I will graph them, I'll show you what they look like graphed, they will intersect at this specific coordinate point at 7, x7, y negative 5. So let me show you that. So this is what these two equations look like graphed, and they do in fact cross, they intersect each other, they share the exact same point of positive 7, negative 5 on my y. Alright, that was 373, number 19. Good luck in your studying.